So let us finish the introduction part of shear force diagram and bending moment diagram. By that we can easily do numericals. So let's start with reactions. Okay, different support have different reaction. How they are going to react if load occurs. Let's see how many reactions have. Let's go for first fixed support. Okay, let's go for fixed support. So the fixed support that first we have. So how many reactions is there? Maximum how many reaction can be there? Maximum there can be 3 reaction. Okay, vertical, horizontal, and rotational movement. So fixed support have exactly the same. It has one vertical, one horizontal, and one rotational movement. Likewise, one vertical, one horizontal, and one rotational movement. Okay, 3 reactions are there for fixed support. So in place of a reaction we have 3 reaction for fixed support. So now let's go for hinge support. So how many reactions are there for hinge support? So from 3 support, vertical, horizontal, and rotational, we have for hinge support we have only 2, which is vertical and horizontal. There is no rotational movement. Okay, the reactions are 2 number of reactions we have for hinge support. These things we have to know before go for any numerical. So another one support is there. Let's go for that, which is roller support. So how many reactions are there for roller support? There will be only one reaction we have for roller support, that is only one. So which one is the question? So the reaction that roller support have is either horizontal or vertical, any one. Okay, so I have drawn 2 type of roller support, both are correct, you can use any one. So the reactions that we have for roller support is either horizontal or vertical, any one support we can take. So let's go for one example so that it will be clear. Let's go for one simply supported beam having one hinge support and one roller support. So how many reactions in total? Hinge support have 2 reactions, which is horizontal and vertical, and roller support have only one reaction, which is vertical or horizontal. So the reaction is 3. Let's go for another example. Let's add one fixed support that which is having 3 reactions, obviously vertical, horizontal, and rotation. So now let's go for some basic points or basic uh, terminologies that you should know before going to or before dive into numericals. So first one is pure bending. So what is pure bending? By the term bending only, by the term pure bending only, we can recognize that a region in which shear force is 0 and bending moment is constant. That region of the bending moment diagram of any beam is called pure bending, or it occurs under pure bending. Okay, let's go for another term, which is point of contraflexure, that I have already mentioned in the last video. So what is this point of contraflexure? So first of all, flexure, in some question they may be used, instead of flexure they may be used inflation, or they may be used virtual hinge. Okay. So what is point of contraflexure? It is generally changing its sign. So in bookish word we can say it is the point in bending moment diagram where bending moment changes its sign. Means it is changing from positive to negative or negative to positive. Okay. So means generally in overhanging beam it occurs or it observed. Okay. So let me draw a point of contraflexion for you so that it will be easier to understand. Above the line it is positive. So first positive, then below the line it is negative. So the point where it is changing from positive to negative, that point is called point of contraflexure. Okay, let's go for pure shear. So we knew that pure bending is what? Now pure shear is what? It is more easier than where we can easily say pure shear is it occurs in the region where shear force is constant and bending moment is zero. Where shear force will be constant but bending moment will be zero. Okay, I am drawing likewise. Shear force is constant and bending moment is zero. Okay, let's go for another one, which is shear span. This is also very important one. A region in which shear force is constant means in a beam and which is having a shear force diagram. In the shear force diagram, if the shear force is constant, or in the region where shear force is constant, at that part only we call shear span. Okay, so let's go for another point where point of contraflexure occurs, where point of contraflexure occurs at internal hinge. Let me draw it for you. Internal hinge means what? Let's draw a series of beam which is connecting, started with fixed, and in between hinge are there. So this hinge is a cause of point of contraflexure. So let's end this video here. Thank you so much. From next there will be numericals.